Hello everyone. In this video, we will be discussing about joints. When we speak about joints, we have two different types of joints. First one is temporary joints. Second one is permanent joints. We will see both in detail. First one is temporary joints. Temporary joints are joints that allow easy disassembling of assembled structures without rupturing the components, and even that is why it is called as temporary joints. It also facilitates fast, easy and cost efficient inspection. So no destructive testing is required for inspection of joints, and repair and replacements also very easy in case of the temporary joints. And these temporary joints are suitable where frequent separation of assembled components is required. Then what is permanent joints? Permanent joints are joints that don't allow dismantling of assembled structures without breaking the components. And the permanent joints cannot be disassembled easily, so inspection, repair and replacement are difficult and costly. Often destructive testing is carried out. Permanent tests or permanent joints are suitable for such applications where separation is usually not desired in the service life. So I can list out many examples for the temporary joints and permanent joints. Examples for the temporary joints: it may be some screw and nut or any kind of machine assemblies, and knuckle joint or whatever kind of cotter joint. Everything comes under temporary joint. Permanent joints means it is welding and different types of welding. We have gas welding, arc welding, and different types of welding, soldering, and riveting. So all these things will come under the permanent joints. Now we will see the differences between temporary joint and permanent joint. So temporary joints allow easy dismantling of assembled components without breaking them, but permanent joints did not allow dismantling of assembled components without rupturing them. Temporary joints are not necessarily leak proof, but permanent joints are usually leak proof. Strength of temporary joint is comparatively less, but strength of permanent joint is high. Usually joint strength is same with that of the components. Temporary joints facilitates fast, easy and cost efficient inspection, and there is no destructive testing is required for inspection of joints. But permanent joints cannot be disassembled easily, so inspection is difficult and costly. Often destructive testing is carried out without damages the assembled structures. Repair and replacement are also very easy in case of the temporary joint, but the repair and replacement are difficult and costly in permanent joint. So in this module we will be discussing two joints. First one is the Cotter joint, second one is the knuckle joint. So the Cotter joint we will be discussing its applications, its purpose, and its design, its failures, and all those things we will be discussing. Not only for Cotter and even for the knuckle joint we will be discussing. And for your university examination, very surely you can expect at least one design content from this joint part. First of all, what do you mean by Cotter joint? Cotter joint is a flat wedge-shaped piece of steel. You can able to see here whatever I am highlighting. No, this particular a wedge shape, a thick a piece of metal steel, we call it as a Cotter joint. And why it is used? This is used to connect rigidly two rods. You can able to see this is rod number 1, this is rod number 2. I want to connect these two rods with the help of this Cotter. So this is used to connect rigidly two rods which transmit motion in the axial direction without rotation. And these joints may be subjected to tensile or compressive forces along the axis of rods. Examples of Cotter joint connections are connection of piston rod to the crosshead of a steam engine, valve rod and its steam, etc. A typical Cotter joint is shown in this particular sketch. One of the rods has a socket and one of your other rocket has a spigot, and where the socket and spigot has been connected with the help of this Cotter insert. Next, we will see when we speak about this Cotter joint design, we should be knowing all the symbols and what and all we will be finding out what kind of stresses is induced. All those things we will be discussing. You can able to see this very clearly. You just try to remember major three components are there. That is a socket, and we have a socket collar, and we have a spigot. And a Cotter is the metal strip which actually helping to connect these socket and spigot. Okay, first is capital P. So here P is nothing but the load carried by the rods. Here I have shown a tensile load. So that load is denoted with capital P. Small d is the diameter of the rod. So where is a small d we can able to see here is, here we can able to see a small d. You can able to see this is small d. And D1 is the outer diameter of socket. This is the socket and the outer diameter is denoted as D1, and D2 is the diameter of the spigot inside. You can able to see inside spigot, that is nothing but D2, and D3 is outside diameter of the spigot collar. So D3 you can able to see this is D3. So the outside diameter of the spigot collar is denoted as D3, and a small T1 is the thickness. You can able to see this is the thickness of the spigot collar, and D4, this is D4, this is D4, this is the diameter of the socket collar, and apart from that we have thickness of the socket collar, that is denoted by C, and small b, that is mean width of the cotton. Mean width why means because the upper side usually will be having more width compared to the lower side, so usually the mean width, the average only will be considered, and the small t is nothing but thickness of cotter. Small t is the thickness of cotter, and small l is nothing but length of the cotter. This p t l is all about this cotter. You can able to see l and t, where in the side view we can able to see. Then small a, it is the distance from the end of the slot to the end of the rod, and sigma t is the permissible tensile stress for the rod's material. We are denoting always the allowable stress only, not yield stress or ultimate stress. Then the permissible shear stress for the cotter material is tau, and sigma c is nothing but permissible crushing stress for the cotter material. And here you can able to see the cross piece section of a cotter joint. A spigot is there, a socket is there, and even a cotter also we can able to see, where a removed part we can able to see very clearly after inserted the cotter into this spigot and socket rods. We can able to see how it is made. And very importantly, this clearance is also shown. That is very important, because without clearance a design cannot be done. Then, so what are the points we need to remind? So a cotter joint is a flat wedge link piece of steel of rectangular cross section, which is inserted through the rods at high angle to their axis. It is uniform in thickness but tapering in width, generally on one side only. Usually the taper is 1 in 30. When a special arrangement like a set screw is provided for keeping the cotter from slackening, its taper may be as large as 1 in 7. The end of the cotter are made narrow to facilitate the hammering for fixing and removing. Cotter joints are generally used to fasten rigidly two rods which is subjected to tensile or compressive stress along their axis. This joint is used to connect two circular rods, and this joint is not suitable where the member are subjected under rotation. So these are all the points we supposed to remember for the cotter joints. And once the design is done means we should be able to draw the sketch again in our answer sheets, and all the values whatever we are finding out, that we have to specify wherever it is required. For example, D2 we are finding out, D1 we are finding out, B means we need to write the values on the sketch, and approximate dimensions also should be specified. Thank you. In the next video, we will discuss about the failures and what are the causes of failures of the cotter joint. We will discuss. Thank you.